So in this video, we're going to go over the transpose of a matrix, one of the easier things that we'll be asked to do this semester. So the transpose of a matrix, here's kind of the formal definition of it, but the idea is with a matrix transpose is you take the rows of the matrix and they become the columns, or the columns of the matrix become the rows of the new matrix. So for example, we have a square matrix here, matrix A, which is a 2 by 2 matrix, 2, 1, 7, 3. The transpose of this matrix is simply the matrix that we get when we take the rows. So here's the row 2, 7, and we convert that row into a column. So the first row becomes the first column of the transpose matrix, and the second row becomes the second column of the transpose matrix. So the rows become the columns, and the columns become the rows. So you can see here column 1 has become row 1. So here matrix B, which is the matrix 1, 2, 2, negative 2, negative 1, 0. And if we want to take B transpose, we just take the columns, or the rows. You can take it from either perspective. So if we do the columns are going to become the rows. So column 1, 2 becomes row 1, 2. This column 2 becomes the second row. So the column 2, which is 2, negative 2, becomes row 2, 2, negative 2. And column 3 becomes row 3. So instead of column negative 1, 0, it's row negative 1, 0. And then something that's useful about a matrix transpose, and that we'll take advantage of, if we have an m by n matrix. Remember that we said if we have an m by n matrix, that we can't, if m doesn't equal m, in other words, if we don't have a square matrix, so if matrix A, for example, or let's say D, if matrix D is an m by m matrix, we can't do D times D because we get an m by n and an m by n. If m and n aren't the same number, these inner numbers don't match. We don't have the same number of columns as we do rows, so we can't take dot products to generate the matrix entries. But if we do a transpose matrix, see here we have a matrix that's a 2 by 3. Because we interchange columns and rows, this is going to become a 3 by 2 matrix. And so the product, the 3's match. So the product B times B transpose always exists, which is a useful property of a matrix transpose. You can always multiply a matrix by its transpose. So we have one more here, C. C is the row vector, 1, 2, negative 3. So C transpose then is simply the row vector converted into a column vector. Row 1 becomes column 1. And so we have a nice column vector here. Sometimes if we want to take a dot product, for example, if we start with the column vector, let's say I start with the column vector A equals 1, 2, and I have a row vector B equal to 1, 4, and we want to talk about doing A dotted with the dot product of A and B. Sometimes what we'll do is say, hey, take A transpose dotted with B, and the reason for writing it that way sometimes is A transpose, this column vector now just becomes a row vector 1, 2, and it's kind of written, it's then written in the same format. We have a row vector dotted with a row vector. So A dot B, where we're talking vectors, can always be written as A transpose dotted with B as well.